So, how did you do with the questions? Great job, everyone. Have you ever heard of the term remote sensing? Well, it's a rather simple activity that we do every day of our lives. In fact, as you're watching this program right now, you're actively engaged in remote sensing.
Coming from the screen is energy in the form of visible light. The radiated light is detected by sensors in our eyes, which collect data about the energy and transmit that information to the brain. In the brain, those data are interpreted and meaning is attached to it. We experience such sensations as heat. We react to chemical signals from food. We understand the textures of different surfaces, all without coming in direct contact. Now, this can be called remote sensing.
Now, at NASA, remote sensing has a slightly more technical definition. So, let's talk to an expert in that field, Dan Irwin at NASA Marshall Space Flight Center.
Thanks, Jennifer. Remote sensing is gathering information about the Earth from a distance. Information can be collected about the land using special cameras or instruments located just a few feet above the Earth's surface, or an airplane flying hundreds to thousands of feet above the ground, or even from a satellite orbiting hundreds of miles above the Earth. Now that you know what remote sensing means, let's talk about terrestrial remote sensing. Terrestrial refers to the Earth, so terrestrial remote sensing means gathering information about the Earth from a distance. This involves the detection and measuring of electromagnetic energy coming from different objects made of various materials. The spectrum of sunlight reflected by the Earth's surface contains information about the materials it is made of. Since sand, rocks, crops, and dense vegetation each have different temperatures and reflect light in different ways, sensors can reveal clues about past human activities, such as agriculture, that our eyes may not be able to detect. Most of the universe is invisible to humans. In fact, the only part that we can see with our detectors, or our eyes, is part of the electromagnetic spectrum known as visible light. If the entire electromagnetic spectrum were scaled to the size of the Earth's circumference, the portion of visible light would be as wide as a pencil. But scientists have been able to build sensors that can see portions of the electromagnetic spectrum that we cannot. For example, Norbert is standing next to a hot stove. He cannot see the infrared energy coming from it, but the sensors in his skin send data to his brain that's interpreted as heat. He knows to move away. We know to protect our skin from ultraviolet radiation. While we cannot see this energy with our eyes, we can see its effects on our skin. So what is the electromagnetic spectrum? The electromagnetic spectrum is just a name that scientists give to a bunch of types of radiation when they want to talk about them as a group. Radiation is energy that travels and spreads out as it goes. Visible light that comes from a lamp in your house or radio waves that come from a radio station are two types of electromagnetic radiation. Other examples of electromagnetic radiation are microwaves, infrared and ultraviolet light, X-rays and gamma rays. Hotter, more energetic objects create higher energy radiation than cooler objects. Visible satellite images are similar to pictures a photographer might record, in that they relay and display reflected light just as our eyes would see the scene. As long as light is available, land features like mountains, river courses, lakes, silt runoff from rivers into the sea, and coastlines are clearly visible. But what about the energy that we cannot see? Infrared images display gradients of temperature differences. Infrared sensors pick up data both day and night. They show the pattern of heat released from the Earth. Heat-producing areas such as warm water currents or cities with heat-absorbing concrete and asphalt, and heat-producing cars, people, and factories are bright spots on the infrared images. Archaeologists use data collected by sensors located on satellites to reveal clues about the past temperature and chemical composition to find potential agricultural and other areas of human occupation. For example, let's take a look at a satellite image of the Sahara Desert in Africa. Right now, you're looking at an image in visible light as if you were in an airplane or a spacecraft looking out the window. A 50-kilometer wide path from the Shuttle Imaging Radar mission over the Sahara is now shown superimposed on the previous image. The radar penetrated a few meters beneath the desert sand to reveal a prehistoric river system. Archaeologists have found artifacts and animal remains showing that this was once a moist and densely vegetated area. While each of these instruments creates a different image, imagine if they could be combined to give scientists and researchers new information about a particular area. That's what GIS does. GIS stands for Geographic Information System. GIS is a system of computer software, computer hardware, data, and humans that help manipulate, analyze, and present information about a specific geographic location. The human part of this system is the thinking explorer, who's key to the power of GIS. Simply put, GIS combines layers of information about a place to give you a better understanding of that place. What layers of information you combine depends on what you want to know. If you want to find the best location for a new sporting goods store, you might want to know the traffic pattern and population density. You might also want to know if there are any potential customers living nearby.